In this video, we're going to look at trig functions in the coordinate plane. So the first thing we want to recall is some right triangle trigonometry. So remember, this is my reference angle. So this would be my opposite side, and this would be my adjacent side, and this is my hypotenuse. If I'm on the unit circle, then we know that this hypotenuse is 1. So if we think about this, if we go cosine, the cosine of theta, cosine is adjacent over hypotenuse. So in this case, that would be adjacent over hypotenuse. So my adjacent side is actually my x coordinate, and then my hypotenuse, remember, is 1, so we get x over 1. So we really end up with the cosine of theta is just equal to x. Similarly, we can do the same thing with sine of theta. So sine of theta is my opposite over my hypotenuse. And in this case, my opposite is going to be my y coordinate, so y over my hypotenuse, which is 1. So we end up with sine of theta is equal to y. So really, this coordinate here, which is xy, is also cosine theta, sine theta when I'm on the unit circle. If we're stretching it by a particular factor, then we can say that this would be your radius times your cosine of theta, and your radius times the sine of theta. If it helps, just remember alphabetical order, x comes before y, and then when we think of it in terms of trigonometry, cosine comes before sine alphabetically. Also, we can think about the tangent. Tangent of theta, remember, is opposite over adjacent. So in this case, that's going to be y over x. So our tangent of any angle rotation in the circle is just y over x. Think of tangent as slope, y is on top. So your slope formula is change in y over change in x. Tangent and slope are very closely related. So tangent, think slope, and then it's always y on top, x on the bottom. So if we kind of take this and transfer it to some general ideas here, let theta be any angle in standard position whose terminal side contains the point -3, -5. So they're giving us a point, so I'm just going to kind of visualize that. So we're going to plot this point. So just think about what quadrant you would be in. So -3, -5 would be in quadrant 3. Once you have your point plotted, I want you to draw a segment from your point to the origin and from your point to the x-axis, creating a perpendicular, so you now have a right triangle. Your theta value is always going to be at that origin, and it's always between the hypotenuse that you've drawn and the x-axis, so the horizontal. So now we know that this is -3, and we know this is -5, and I know that because of the point that I was given. Then this is my radius. So the first thing I want to do is figure out what my radius is. And to do that, I'm going to use the Pythagorean theorem. So we're going to go -3 squared plus 5 squared, -5 squared equals r squared. So then we get r is plus or minus the square root of 34. Your radius always represents the distance that the point is from the origin. So your radius is always going to be the positive value. So I'm going to get radical 34 there. Now we want to write the 6 trig functions, so it doesn't matter what order we do them in, so I'll just go cosine of theta first. So cosine of theta, remember, is adjacent over hypotenuse, so -3 over radical 34. Don't worry about rationalizing on these. Then we're going to do sine of theta is opposite over hypotenuse, so -5 over radical 34. And then we've got tangent of theta. So opposite over adjacent is -5 over -3, which is just going to give me 5/3. So those are my trig functions, and then we need to do the reciprocal functions. So remember, the reciprocal of cosine is secant. So secant of theta is going to be -radical 34 over 3. Cosecant is the reciprocal of sine, so cosecant is going to be -radical 34 over 5. Cotangent is the reciprocal of tangent, so cotangent is going to be 3 over 5. So this one is similar process, but they're presenting us with some different initial information. So they're asking us to find cosine and tangent using the given information. We know the sine value, and we know that the tangent value is less than 0. So the first thing that we want to figure out is, what quadrant am I working in? So the sine value, my sine of theta is 3/7, so that's a positive value. And then my tangent value is less than 0, so tangent is a negative value. So I need to figure out what quadrant has a positive sine value but a negative tangent value. So remember, if I'm in quadrant 1, all my points are positive, positive. If I'm over here in quadrant 2, they're all negative, positive. Down here in quadrant 3, they're negative, negative. And here in quadrant 4, they're positive, negative. And then remember, your x-coordinate is always your cosine value and your y-coordinate is always your sine value. So here, if my sine value is positive, that's my y-coordinate. So I'm either in this quadrant here, I'm in quadrant 1, or I'm this quadrant here, I'm in quadrant 2. And then my tangent value is negative, so my tangent value is when I divide the x and y coordinates here. So if I do positive divided by positive, I'm going to get positive here. Here, if I do a positive divided by negative, I'm going to get negative here. So this is the quadrant that I know I'm in based on the information that was given to me. So I'm just going to place a point in that quadrant. It doesn't really matter where, as long as you're in the appropriate quadrant. And then again, just like we did before, we're going to draw a segment from the point to the origin and from the point to the x-axis, always to the x-axis. And then I'm going to put my theta always at the origin between the hypotenuse and the x-axis. Now I know my sine value is 3/7, and I know that sine is opposite over hypotenuse, so now I'm going to fill those in. So opposite from theta, this is 3, and my hypotenuse is going to be 7. What I'm missing here is my horizontal piece and this x value. So I'm going to use the Pythagorean theorem to find that x value. So x squared plus 3 squared equals 7 squared. We end up with here is x is plus or minus 2 radical 10. So then we go back and we look at what quadrant we're in to decide if the value that I was finding should be positive or negative. Remember on the last example we said the radius is always positive, so if you're finding the hypotenuse, it's always positive. But if you're finding an x or a y, the horizontal or the vertical, it can be positive or negative depending upon your quadrant. So if I'm over here in quadrant 2, I'm finding my x-coordinate, I know that's negative, so this is negative 2 radical 10. Then I can go back and I can find what I was asked for. So I was asked to find the cosine value. So cosine of theta is, remember, adjacent over hypotenuse, so negative 2 radical 10 over 7. And then also we were trying to find the tangent of theta. So tangent theta is going to be opposite over adjacent, so 3 over negative 2 radical 10. Again, don't worry about rationalizing here. All right, so on this example, it's similar to the last one. We're going to find cosine and tangent again, given that secant is 3 and sine is greater than 0. So first of all, if I have secant, I'm going to think, okay, then that I know the reciprocal of that. So the reciprocal of secant is cosine, and the reciprocal of 3 is 1/3. So if you start with secant, cosecant, or cotangent, just find your reciprocal function, and it's usually a little bit easier to think about. So now what I know is that my cosine value is positive, because it was equal to 1/3, and then my sine value, they told me was greater than 0, so I'd also know that one's positive. So again, now I'm going to think about what quadrant I could be in where my cosine and my sine value are both positive, and so that's going to happen in quadrant 1 where it's positive, positive. So now I'm going to put a point in quadrant 1, I'm going to draw that line to the origin and to the x-axis. I'm going to put my theta value at that origin point. So now I know my cosine value, which is adjacent over hypotenuse. So my adjacent side is 1 and my hypotenuse is 3. And then what I'm going to do is try to find this y value then. So always when I'm finding that missing side, I'm going to use the Pythagorean theorem. So here I'm going to go 1 squared plus y squared equals 3 squared. So I end up with here y is plus or minus 2 radical 2. If I come back to my quadrant, I'm in the first quadrant, I'm finding my y coordinate, so I know it should be positive. So this is 2 radical 2. Okay, so if I look at what they asked me to find, they asked me to find cosine of theta. So cosine of theta actually we already found, which was 1/3. So we already had that, and then we need to find the tangent of theta. So tangent of theta is opposite over adjacent, so 2 radical 2 over 1, which is going to give me 2 radical 2.